Programming is about organizing and manipulating data. Data structures are the tools we use to do this effectively. They provide ways to store, access, and modify data in our programs. Think of them as containers with specific rules for holding and managing data. Understanding data structures is crucial for writing efficient and well-organized code. Lists are the workhorse of Python data structures. Imagine a shopping list. You have items in a specific order. Python lists work the same way. They are ordered, mutable, and allow duplicate values. Creating a list of fruits. Python fruits = apple, banana, cherry. Accessing elements by index. Python print fruits 0. Hash output apple, adding an element. Python fruits append orange. Removing an element. Python fruits remove banana. Looping through a list. Python for fruit and fruits. Lists are versatile. Use them for storing collections like student names, to-do lists, or even game levels. Dictionaries excel at storing data in key-value pairs. Think of a real dictionary. You look up a word, key, to find its definition, value. Creating a dictionary of student grades. Python grades = Alice 90, Bob 85, Charlie 95. Accessing values by key Python print grades Bob. Hash output 85. Adding a new entry Python grades David = 80. Looping through a dictionary. Python for name grades.itms. Print f name grade. Dictionaries are perfect for representing relationships between data like user profiles or product information. Sets are all about uniqueness. They are unordered collections that only store distinct elements like a set of unique stamps. Creating a set of colors, Python colors = red, green, blue. Adding an element, duplicates are ignored. Python colors, add red. Checking for membership, Python print green in colors. Hash output. True looping through a set. Order is not guaranteed. Python for color in colors. Print color. Use sets when you need to ensure data uniqueness, such as tracking unique website visitors. Section 5. Python tuples, immutable data collections. Tuples are like lists, but with a key difference: they are immutable, meaning you cannot change their contents after creation. Think of them as read-only lists. Let's take a look at an example. Imagine creating a tuple of coordinates. You'd write something like this. Coordinates = 10, 20. You can access elements by index, just like in a list. For instance, print coordinates at index 0 would give you 10. However, if you try to modify a tuple, you'll run into a problem. For example, attempting to set coordinates at index 0 to 15 will raise a type error, because tuples do not support item assignment. You can, of course, loop through a tuple. For chord in coordinates, print chord will output each element in the tuple. Tuples are great for representing data that should not be modified, such as database records or configuration settings. Section 6. Choosing the right data structure. Selecting the appropriate data structure is crucial for code efficiency. Consider these factors. Order. Do you need your data in a specific order? Lists preserve order while sets and dictionaries do not. Mutability. Will you need to change the data after creation? Lists and dictionaries are mutable, while tuples are immutable. Uniqueness. Do you need to ensure all elements are unique? Sets only store unique values. Key value pairs. Is your data best represented as key value pairs? Dictionaries are ideal for this. Section 7. Efficiency tips for Python data structures. List comprehensions. Use list comprehensions for concise ways to create and manipulate lists. For example, creates a list of squares from 1 to 5. Dictionary method. Avoid exceptions when accessing dictionary keys by using the method with a default value. For instance, returns the value for key or 0 if it doesn't exist. Set operations. Leverage. Set operations like union, intersection, and difference for efficient set manipulations. For example, and the union set would be, which results in. Section 8. Applications of data structures in real-world problems. Social media feeds. Lists can store posts in chronological order. E-commerce shopping carts. Dictionaries can hold product IDs as keys and quantities as values. Recommendation systems. Sets can efficiently track user preferences and recommend similar items. Data analysis. Data structures are fundamental for storing, cleaning, and analyzing large data sets. Section 9. Conclusion and further learning. Mastering data structures is fundamental to becoming a proficient Python programmer. We've covered the basics of lists, dictionaries, sets, and tuples. Remember to choose the right data structure based on your needs and apply efficiency tips for optimal performance. Continue exploring advanced data structures like stacks, queues, and trees to expand your programming toolkit.